Welcome to Fix It Home Improvement, covering projects that every homeowner should know and great products for home and garden.
Hi, I'm JC, and this is where we share weekly home improvement tips. I'm here with my co-host, Cindy.
Hello, JC.
Hi, Cindy. This week, we're going to be talking about heat pumps, and we'd like to thank Tracy Sykes for sharing and liking the podcast. And if you're listening to this between January 27th and January 31st, 2019, you can get a free download of our new book. It's called Home Improvement Solutions, What Every Homeowner Should Know, Book 6. You can download it from Amazon onto any device, and after January 31st, it's only going to be $1. So we'd really appreciate a download.
And a good review.
In the 1750s, Benjamin Franklin experimented with evaporating liquids to produce a cooling effect. In the 1820s, Michael Faraday discovered that evaporating and condensing ammonia could produce cooling. And then in the 1850s, James Harrison created a vapor compression refrigeration system, and he was able to create ice. And these early refrigerants were usually flammable and toxic. So in the 1920s, manufacturers worked together to make safer refrigerants for people, but they discovered around the 1970s that these new refrigerants were damaging the ozone layer in the stratosphere, which protects us from ultraviolet radiation. And it wasn't until the 1990s when many nations put bans in place to eliminate many of these ozone-depleting refrigerants. And heat pumps use refrigerants, and the main styles are air-to-air, air-to-water for hot water heating, and geothermal, which transfers heat from the ground for heating and cooling. Air source heat pumps that are using the existing ductwork in your home, and mini-split heat pumps that can heat and cool a room or multiple rooms, and they're not connected to ductwork, are the most popular, and that's what we'll focus on this week.
Super excited about it.
Air source heat pumps have two units. One outside unit that looks like a traditional central air conditioner unit, and in the summer, a heat pump is going to work just like a central AC unit, although most of these are actually going to be more efficient at removing humidity from your home. And then you're going to have an indoor unit. If you have a gas or electric furnace that's connected to ductwork throughout your home, the heat pump is going to be using the furnace to move warm and cool air through your house. If you don't have central air and you're planning on upgrading your furnace and adding central air, you can get a more efficient furnace if you're in cool or cold climates, and you'd use the furnace as backup for very cold outdoor temperatures, and you'll be using the heat pump like a traditional air conditioning unit. If you're in warm or hot climates, you would have an indoor air handler generally to move the air. And this is where you'd want a professional to help analyze your climate and your location to decide what type of unit you'd be using inside.
So in cold climates, you're using the furnace as a backup?
Yeah, what's interesting is most heat pumps are going to draw heat energy out of the air even till it gets around freezing. But then you can't really draw enough heat energy out of the air. So the indoor unit at that point would either have a heating element, or if you have a gas or an electric furnace, that heat pump is going to turn off and then the furnace takes over until the outside temperature rises. If you're in a cool or cold climate, dual fuel heat pumps are designed to work with gas or oil forced air furnaces. The heat pump is going to work to cool the air in hot weather, and then it heats the air in cool weather. When it gets too cold, your furnace takes over. And if you hear the term balance point, it's the temperature where the heat pump can't extract enough heat to be effective.
Okay.
Some of the new heat pumps are getting more efficient at drawing heat out of colder air. And I spoke to Andy from Fujitsu, and we've talked to him before on the podcast. Fujitsu has some models that can work down to negative 15 degrees Fahrenheit.
Wow.
But most systems I looked at, they work well to around freezing.
Okay. Does having a heat pump in cold climates make sense?
So it's one of the questions I asked Andy, and he said to work with a contractor, analyze your local climate, the cost of your utilities, whether you're using electric, natural gas, propane, or oil, because in some cold climates, if you have natural gas, a high-efficiency gas furnace may be the best system for heating your home, but in most climates, moderate and warm especially, a heat pump is going to be much more energy efficient. Andy said when you're shopping for a contractor, they should be NATE certified, and it's N-A-T-E. That's the North American Technician Excellence Certification.
Sounds official.
Or they should be a senior level efficiency analyst, which is even higher. And they should be using the manual J calculation to figure out the size of the units. And they're comparing a lot of factors in your home. We've talked about this before, like the amount and location of your windows, doors, insulation, home orientation, your local climate, how many people are in your kitchen at one time. It's pretty in-depth. And he also said most furnaces are going to work with a heat pump, but you're probably going to want to upgrade your thermostat. And for dual fuel heat pumps, you need a dual fuel thermostat.
I don't think you've explained yet how a heat pump works, which is kind of important.
So for the air source systems, whether it's a mini-split system or a heat pump that's using the ductwork in your home, you're going to have an outside unit and an inside unit, and both of these units are going to have coils to move the refrigerant. There's a compressor and expansion device. When the system is cooling your home, the outdoor unit works like a central air unit. It's absorbing the heat from inside your home, and it releases it to the outside, and it's lowering the temperature of the coils inside your house. When you're heating your home, the heat pump reverses the flow of the refrigerant, and now it's absorbing heat from the outside. It's releasing it inside by heating up the coils, and then a fan is blowing over those coils to move warm air into your house. So the refrigerants are absorbing and transferring heat as they go from a liquid to a vapor. Water is going to turn into a vapor around 212 degrees Fahrenheit. R134A is refrigerant that turns into a vapor at negative 15 degrees Fahrenheit. And R410 becomes a vapor at negative 50 degrees Fahrenheit. So refrigerants can boil at very low temperatures. And the heat
Why do you seem so excited about that?
It's wild, isn't it? The heat pump, it's using a compressor to increase pressure and generate heat. Then that heat is released in the coils just past the compressor. The refrigerant then goes to an expansion valve, and as it expands, it drops in temperatures in the coil after the expansion valve. So your heat pump can reverse the direction of the refrigerant depending on whether you want heat or cooling. If you have a forced air furnace and ductwork throughout your home and you're planning on replacing your furnace or central air unit, you should look at the features and benefits of a heat pump as part of your system. They can also be potentially safer because they're not using combustible fuels for heating. They're not producing carbon monoxide. If your existing furnace and air conditioning doesn't keep a room or areas of your home comfortable, you can add mini-split systems. So these are ductless heat pumps that can heat or cool a room or multiple rooms.
So you're adding a mini-split to your existing system?
Right. You would have an outdoor unit, and it would be connected to one or more indoor units. And usually they're wall-mounted, like a wall air conditioner. When I talked to Andy, Fujitsu has mini-split heat pumps that only need a 2 or 3 inch hole in the wall, and you're going to run your refrigerant and your electrical through there, and the indoor unit is mounted over that hole. And this style is the most common. You can also have other options if you want vents in your ceiling, or you can get a floor-mounted unit so it's not so obvious.
Okay.
What's great about a mini-split system is the main components are outside. So the indoor unit is going to be very quiet compared to a window or sleeve air conditioner. And Andy said they have one system that uses one outdoor unit and up to 9 indoor units, and each unit is controlled separately. So if you don't want to heat or cool the whole house because you primarily only use a couple of rooms, or if
Maybe
some...
you should move then.
Yeah, move into a condo. Or if some areas of your house aren't as comfortable as they could be, you can just add a mini split heat pump in those rooms. It's going to be much more comfortable and you're going to be using less energy.
How long does a heat pump last?
The Consortium for Energy Efficiency says the average lifespan of a heat pump is about 15 years.
What should you be comparing?
I would compare the warranties, what they cover, what's required for maintenance. For products like a heat pump, the manufacturer is going to require that it was installed by a licensed HVAC technician, and they're going to be able to help you with the size of the unit, how energy efficient it should be for your location. And when you're getting quotes, see if they've been trained by the manufacturer of the brand you like. Most companies are going to have recommendations on their website for authorized dealers. And when you're comparing quotes, get every detail in writing. If they're replacing parts, will they dispose of the old unit? Are you getting a new thermostat or zone controls? Are you setting the outdoor unit on a pad, or are they going to provide a new one for you? You want to get it all in the contract, and then find out if they're going to be using the manual J calculation.
Okay.
Compare SEER and HSPF. SEER, S-E-E-R, is the Seasonal Energy Efficiency Ratio, and this is how efficient your system cools for the whole season. The higher the number, the more energy you're going to save. HSPF is the Heating Seasonal Performance Factor, and this is how well your unit heats over the season. And the higher the number, the more efficient it's going to be, the more money you're going to save on your energy bill. The Department of Energy has new minimums for split system heat pumps, 14 SEER and 8.2 HSPF.
Exciting.
Units that are AHRI certified have the energy ratings tested by a third-party lab for performance.
Are we supposed to know what that means?
So AHRI is air conditioning, heating, and refrigeration, and you may need an AHRI certified unit or a certificate of certified product performance from your HVAC technician for rebates or tax credits. And I would check rebates and incentives and find out what documentation you need before you sign a contract. So Energy Star models are going to be more efficient than standard units. And some areas you can get a tax credit for having an Energy Star heat pump. I would check my local village, the Department of Energy, your local utility company, because these rebates change from year to year and by location.
Okay.
If you're in a warm or hot climate and not using a furnace with your heat pump, you should check to see what type of backup heat strips or elements the unit has for cold weather. And for dual fuel units where you're using a gas or oil forced air furnace, you're going to need a special thermostat. Also ask about zoning. Your contractor can put dampers in the ductwork and thermostats in multiple rooms or levels, and now you can adjust the temperature in each area to reduce your energy costs or just balance the temperature throughout your house. And I would also check and confirm the ductwork is sized properly for your unit if you're using a ducted unit. Compare whether the compressor is single speed or two-speed. A two-speed compressor is going to save energy and last longer. You can also get a scroll or piston compressor. A scroll is going to be more efficient, and some produce up to 10 degrees warmer temperatures, and they're going to use less energy.
Wow, I'm excited as you are.
Variable speed or multi-speed motors for the fans on the inside and the outdoor units are going to reduce noise and will be more energy efficient. For hot climates, you want to look for low-speed fans that run longer to reduce humidity in the summer and maintain more consistent temperatures. You should compare the decibels for the noise level and ask about noise-reducing platforms. So this is for your outside unit, and you want your outdoor unit on some type of platform. Also, if you have snow in your area or you get a lot of snow, there are special snow platforms. For your thermostat, look for programmable and your Wi-Fi options. There's a lot of new features on these. For cool and cold climates, you want an outdoor unit that will defrost and de-ice the outdoor coils if they freeze up. And I've got some companies with top-rated heat pumps. Fujitsu, it's F-U-J-I-T-S-U. Carrier, C-A-R-R-I-E-R. Lennox, L-E-N-N-O-X. Trane, T-R-A-N-E. York, Rheem, R-H-E-E-M. Amana, and American Standard. And I would check reviews on the specific models I'm looking at when I'm comparing.
Okay. Do you have anything else to add?
Get a free download of our new book, Home Improvement Solutions, What Every Homeowner Should Know, Book 6, from January 27th to the 31st. And after it, it's only going to be $1. We'd really appreciate a download.
Let's wrap this up.
You can subscribe to our podcast on Apple Podcasts, Google Podcasts, CastBox, the Pandora mobile app, or your favorite podcast app.
If you enjoyed it, please leave us a review.
You can check out our home improvement videos on our YouTube channel, Fix It Home Improvement.
And you can subscribe to that as well.
You can download our books on Amazon, books 1 through 6 now.
If you enjoyed it, please leave us a 5-star rating and review.
You can email us at fixitpodcast@gmail.com, and you can follow Cindy on Twitter at FixItCohost, and you can also follow us now on Instagram, Fix It Home Improvement.
Thank you for listening.
Talk to you next week.